Okay, so Assalamualaikum and good day everyone. My name is Muhammad Faizifah Benjamin. I'm from Section 8. So for this computer organization and architecture project, I selected Cinebench 2026 as my benchmarking tool. In this video, I will demonstrate how to install and use Cinebench, execute folder A and B, obtain the required benchmark result, and explain the finding based on computer organization and architecture concept. Okay, so this is the interface for Cinebench 2026. So Cinebench 2026 is a CPU benchmarking application developed by Maxon, and it uses the Cinema 4D rendering engine to render a complex three-dimensional scene. Unlike static benchmarks, Cinebench perform realistic rendering tasks that heavily utilize the processor. These benchmarks support both multi-core and single-core benchmark testing. The multi-core benchmark evaluates how efficiently all processing cores work together, while the single-core benchmark measures the performance of one processor core. In computer automation architecture, Cinebench helps us understand concepts such as CPU execution time, instruction pipeline efficiency, throughput, and parallel processing. Okay, now I will show you how to download Cinebench website on Windows. So first, we go to this website link. Make sure it's official for Maxon, and then is the download. So we will choose the Cinebench 2026 for Windows x86 64. Then download. After you download it, you download the zip file. So now you go to the file. This file, you create a folder, then put the zip file here, and then you extract, extract the file to it, and then you got all this thing. So after you got all this thing, then you click on the Cinebench application, then run as administrator. Then you will launch this Cinebench application. Okay, now we're going to complete the workload. So workload is to evaluate multi-core performance. The benchmark was configured to run for 10 minutes. During this benchmark, Cinebench distribute the rendering workload across all 14 processor cores and 20 threads. This demonstrate that where multiple instructions streams execute simultaneously. The benchmark also evaluates CPU execution time, throughput, and pipeline separation efficiency. Since all cores are active, the processor can complete more rendering tasks within the same amount of time. Okay, so now we go to work multiple threads. Start preparing, and then we will wait until timer works. After timer, then it will display the point for CPU clock. Okay, so actually, you can check the task manager. So actually in task manager, during the multi-thread benchmark, all processor cores and threads are heavily utilized. This illustrates the mechanism and high speed throughput. Okay, so as you can see, this 100% for this performance. And then so after 10 minutes waiting, my result for CPU multiple threads is 3006 points. This indicates that the total performance and sustainable work such as video editing, video rig, and engineering simulations. So now we go to we go to single text tool. Click start. So next is workload B. Unlike the previous benchmark, only one processor core performs the task. This benchmark measures instruction partner efficiency, single core performance, and maximum boost clock. And since only one part, then can increase the operating frequency of the core, allowing it to execute structural point. So that's okay now. So after 10 minutes, my single core for my CPU get 439 points. So yeah, as you can see, it's much lower, much fewer than the last. And also for task managing, if you compare it while we do the vertical test, it's much higher. It's like let's see, and if we do the single test, it's much lower. Like averaging that we do 20 something 30%. So yeah. Okay, so comparing both workloads, the multiple core benchmark achieved the 642, and while single core benchmark achieved only 439 points, this means the multiple score is approximately 8.2 times higher compared with the workload, which is split across all available percentages. So from a computer organization architecture perspective, this demonstrates the importance of parallel processing to improve processor throughput, workload element revenue state level parallelism, dan background declaration. Workload B, level instruction management models, background efficiency, and process frequency. Together, these two benchmark shows how modern multi-core processors will perform. With external computational performance while maintaining strong single core capability. Okay, so in conclusion, Cinebench is an effective CPU benchmarking tool for writing processing for mass resilience to level. The benchmark will demonstrate several of the computer automation application concepts including CPU execution time, throughput, and structuring pipeline and parallel processing. Most of the benchmark result return for Alpha 14 and 500 Hz processor performed well in both multiple and single elements. It's easy to learn for the moment professional application. There's working for what you want to do. So now we will move on to the next student.
Hello, my name is Muhammad Zain Faris. For this project, I need to benchmarking the storage subsystem using Crystal Dismark. Okay, the tool I use is the Crystal Dismark version 9.0.3. Uh, that measure the read and write performance and storage device. I run this on my laptop, of which has a Micron 2400 NVMe SSD and has 512 gigabytes in capacity. Okay, before running the branch market, I checked the driver help using the crystal info here. Which means the health status is 90%, which is good, and the current temperature is 42 degree. So I also open Task Manager to monitor the disk active time and transfer speed in real time while the benchmark run, so I can observe how the driver respond under load. Okay, you can see here. Okay. Okay, for this project, I need two specific test profile, which is the RND4K, and the below is Q32T1. Yeah, this one. For workload A. For workload B, I need to use SEQ64K, Q1T1 for. Okay, now I will start the running. I will running this. Okay. Okay, as you can see when now as you can see when the crystal dismark start writing data or read, this active time graph in task manager spike up to near 100%. As you can see, the transfer rate here coming along with it. This show the drive is under heavy load during the write or read test, which is lined up with the write speed which we are seeing in crystal this month. Okay. After 4 to 5 minutes, the test is done, and now for the result, the RND4K 3 Q32T1. As you can see, the read has 32,320.10 MB per second, and the write has 71.38 Mbps. Okay, for the next test is the SEQ64K Q1T1, which has read about 509.89 MB per second, and the write has 914.007 Mbps. Okay, unlike the previous test, this one transfer data in one continuous stream without queuing, so it reflects the drive raw sequential throughput and cache buffering behavior. Okay, and comparing both results, workload A show how command queuing allow the ASD controller to handle many random requests in parallel, improving IOPS. And work, workload B show the driver baseline sequential performance, where the write speed is higher due to the drive cache based buffering. As you can see also on the temperature, it rises to 46 before this is 42, so it increased about 4 Celsius during the test. I think that's all for the benchmarking. Thank you.